Hey guys, let's look at how to plot sine functions and cosine functions in this video. So let's begin with y equals sine x. So we know that this has an amplitude of 1. It's really 1 times sine x. And a regular sine graph has a period of 2 pi. So remember, period tells us how long across the x-axis it takes for one curve to occur. So if I do that, the period being 1 tells us that we're going to have a height of 1 and -1. And the period being 2 pi tells us that from 0 to 2 pi, 0 to 2 pi is how long one cycle will be. So let's split 0 to 2 pi into 4 parts. So if we do 2 pi divided by 4, that gives us 1 pi on 2, so half a pi. So if we split 0 and 2 pi into 4, this is pi on 2, this is pi, this is 3 pi on 2, and this is 2 pi. And now we can draw in our graph. Starting at 0, at pi on 2, we'll have our highest point at 1. At pi, we'll be back at 0. At 3 pi on 2, we'll be at our most negative point at -1. And at 2 pi, we'll be back at 0. So now if we connect all these points up, there. So that's what a y equals sine x graph looks like. It has amplitude 1. So that means from 0 to 1, that's the height, from the middle of the graph to the highest point, and from the middle of the graph to the lowest point is 1. And the period, so the distance that one cycle takes up, is 2 pi for a regular y equals sine x graph. So now let's look at another graph, which is y equals 3 sine x. So for this one, we know that our amplitude is 3, and our period is given by doing 2 pi divided by the number in front of x, so which in this case is 1, and that's called b. So our b value is 1. So 2 pi over b gives us our period for any sine or cosine function. And in this case, that will be 2 pi over 1, which is just 2 pi. So we know that our amplitude is 3 and our period is 2 pi. So let's plot that. So our amplitude is 3, so let's mark in 3 and -3. And it's a sine graph, so we're going to begin at 0. And our period is 2 pi. So let's mark in 2 pi. And again, let's split it into 4 parts. So 2 pi divided by 4 was half pi. So if we mark in our points, this will be pi on 2, this will be pi, 3 pi on 2, and 2 pi. Now let's mark in our 4 points. So we're going to begin at 0, and then at pi on 2, we're going to go up to our highest point. At pi, we'll be back at pi. At 3 pi on 2, we'll be down here at -3. And at 2 pi, we'll be back there. So let's mark in our points. Alright, so the only difference between this equation and this equation was that our amplitude A value changed to 3. So our height from the base or the middle of our function changed to 3 rather than being 1 on both sides. And our period still stayed 2 pi. So one cycle took 2 pi in the x direction for us to plot it. All right, let's look at y equals sine 2x. So in this, again, our amplitude is 1, and our b value, the number before x in the bracket, is 2. And remember, our period is given by 2 pi divided by b. So in this case, that'll be 2 pi divided by 2, which is pi. So let's draw that in. So that's 0. Our amplitude is 1. Let's put that up here, and this is -1. And our period is pi. So let's say that's pi. Now we need to split this into 4 parts. So if you do pi divided by 4, well, that's pi over 4. So this will be pi on 4. This will be 2 pi on 4. And this will be 3 pi on 4. And that's pi. So 2 pi on 4 can be written as half pi if we simplify it. But you can leave it as 2 pi on 4. There's nothing wrong with that. All right, so let's draw in our graph. So our amplitude is 1. So at pi on 4, we're going to be at 1. At pi on 2, we're going to be back at 0. At 3 pi on 4, we'll be at -1. And at pi, we'll be back at 0. So let's plot that in. And there we go. So the main thing to note, and so let's compare this to our regular sine x graph. The only thing that's changed is the period. So for this graph, on our x-axis, one cycle went between 0 and 2 pi. For 1 sine 2x, one cycle went between 0 and pi. So this cycle is half of our regular sine x graph. If you were to draw this graph on here, it would look something like this. All right, moving on. Now say we want to graph y equals sine x plus 1. So remember, for this, our base was at 0. Actually, for all 3 of these previous questions, our middle of our graph was at y equals 0. Now, when you have a number at the end saying plus 1, you're shifting that middle up by 1. So let's draw that and we'll see what that looks like. So again, let's get our amplitude first. So this is, if there's no number, it means it's a 1. So our amplitude is 1. And the number here in front of x, if there's no number, it means it's a 1. So b equals 1. And our period will be the usual 2 pi, because 2 pi over b. And b is 1 in this case, so our period will just be 2 pi. But what this plus 1 tells us is that the middle of our graph, instead of being at 0, will shift up to 1. So the plus 1 is doing a translation of 1 in the y-axis. So let's mark in our 0 point first. So this is our new middle. Instead of being at 0, our new middle is at 1. So now let's plot the rest of the graph. Now from here we have an amplitude of 1. So if we do our base 1 plus our amplitude 1, we get 2. So this point will be 2. And our bottom point would be 1. So our base again, minus 1, which is 0. So let's mark in 0 as well. And our period is still 2 pi. So let's mark in 2 pi over here. And let's split that into 4 parts. So that will be pi on 2, pi, 3 pi on 2, and 2 pi. And so let's plot our point. So our starting point, so we start from our base here, which is at 1 now instead of at 0. Then our highest point will be at pi over 2 at the value 2. And then at the x value of pi, we'll come back to our base at 1. Then at our x value of 3 pi on 2, our y value would be the most negative at 0. And then at 2 pi, we'll be back at the base at 1. And then let's join up all the points together. And there we go, we've plotted it. So as you can see, if we compare this to our original graph, all that's happened is instead of drawing it from at baseline 0, we're drawing it at baseline 1. So it's the same graph, but all points translated up by 1. Alright, so let's look at another example. Y equals negative 2 sine x. So again, let's look at what we know. Our amplitude is 2 and our b value is, that's still 1. So that means our period is going to be 2 pi divided by b, which is 2 pi divided by 1, which is just 2 pi. And what this negative tells us is that we will get a reflection about the x-axis. So what that means is our graph will be flipped, vertically flipped. So let's draw that. Let's mark in, so our base is at 0. Then we have an amplitude of 2 and negative 2. And our period is 2 pi. So let's cut that into 4 parts. We're going to have pi on 2, pi, 3 pi on 2. And normally if we were drawing this, we would have plotted in 0. And then now, instead of plotting pi on 2 up here, we're going to come down and plot it at negative 2, back on pi, and then plot up here and then back at 2 pi. And there, now we've plotted it. So let's compare what it looks like with our original y equals sine x graph. So as we can see, instead of doing positive peak, center, negative peak, center, it's a reflection of that. So we're going to do 0, negative peak, 0, positive peak, 0. And that's it. Now we've plotted negative 2 sine x. Let's look at this example where we have got half sine 4x. So by now we know how to do all the different things. So let's just draw that in. Our amplitude is half or 0.5. Our b value is 4. So our period is going to be 2 pi divided by 4, which is 1/2 pi. So let's mark that in. So we're gonna do 0. Let's say this here is 0.5 and this here is negative 0.5, and then our period is up till pi on 2. So let's split pi on 2 into 4. So if you divide that by 4, we're going to get pi on, if we want to divide that by 4, that's pi on 2 times 1 over 4, which is pi over 8. So if we split this into 4 parts, this will be pi over 8, this will be 2 pi over 8, this will be 3 pi over 8, and that's half pi. And we can simplify 2 pi over 8 to be pi on 4. Again, you don't have to simplify this. It's still okay to leave it how you want. All right, so let's mark that in. So again, it's a sine graph. So we're going to go from 0 up to the positive peak at pi on 8, then back to 0, then down to negative 0.5, and then back to pi on 2. And then we can draw it in. And that's it. We're done with that one. Now, lastly, let's look at y equals sine x minus pi. So again, our a value is 1, because if there's no number, it means it's a 1. Our b value is also 1, because there's no number in front of x. X is not being multiplied by anything other than 1. So b is 1, because b is the value that x is being multiplied by. And this value here is c. And c tells us the horizontal shift. So what this tells us is, instead of starting our point at 0, we're going to start our point at pi. So now let's put in this information. Our amplitude is 1, and our period is going to be 2 pi over b, which is 1, so over 1, which is just 2 pi. So our period will now start from pi. So we'll do pi plus 2 pi, which is this distance, which is 3 pi. So this here is 3 pi. And this distance between these 2 points is 2 pi, because that's our period. So again, let's split 2 pi into 4 parts. So 2 pi over 4 is pi on 2. And we're going to split, so if this is pi, let me put 3 pi over here. And then we can split this into 4 parts. So this first point will be pi plus pi on 2, which is 1.5 pi. This will be 2 pi. This will be 2.5 pi. So let me write that as 5 over 2. And let's write this as 3 over 2 as well. So this will be 3 over 2 pi, 2 pi, 5 over 2 pi, which is 2.5 pi, and 3 pi. And then the rest, we just plot it as we normally would. There we go. Now we can bring this back and keep going back to 0. So because remember, a sine graph in reality is infinite. It keeps repeating again and again using this same cycle. So if I took this further back, it will look like this. And I can keep going, just negative here, here, here. Or we can stop plotting it there. So what this has done, if I remove this again, is instead of starting at 0 in the x direction, we have moved that across to start at pi. And that's what this c value tells us. It tells us the horizontal shift. And remember, we don't include the sine with that. So this is the normal form of what a sine graph would look like. So the negative sign is not a part of c. So in this case, because it was x minus pi over here, our c value is just pi. And that means we're going to move in the right, positive x direction. If instead we had a question that looked like sine x plus pi, then our c value would be negative pi, because this is the same as x minus pi. Because negative and negative gives us positive. So because c is minus pi, that would mean we are moving to the left from 0. And we would have started our graph from negative pi over here rather than positive pi. So let's do a recap. So A tells us our amplitude. So how far from the center of the graph is your highest point and the lowest point. B helps us get the period. So we do 2 pi divided by b to get our period of one cycle. C tells us the horizontal shift. So instead of starting at 0, maybe we're starting at pi, maybe we're starting at negative pi. And D tells us our vertical shift. So it tells us instead of having our base here at 0, at y equals 0, it might be moved up to y equals 1 or y equals negative 2. And that's a summary. So basically we've got the normal form is y equals a sine b, x minus c plus d. A is our amplitude, period is given by 2 pi over b. C is our horizontal shift. Remember, it's just c, it doesn't include the negative sign. D is our vertical shift. And if we have a negative sign in front of our sine function, then it means that it has a reflection across the x-axis. It's vertically flipped. All right, that's the conclusion of this video. I want you to keep in mind that these same rules apply for cos x. So you would begin by plotting y equals cos x, and then all the values of a, b, c, and d have the same effect on the cos x function as it does on the sine x function. All right, thanks for watching.